I'll just give our little welcome spiel. It looks like I'm familiar with most of the people in here, but this weekly code talk is put on by vSchool. vSchool is a coding boot camp dedicated to getting students into their careers as fast as possible, as responsibly possible. Lainey, if you can see Lainey on the screen, she is our outcomes director, and she is the reason why we have such great outcomes and get people into jobs so quickly. We have two programs. We've got a full stack web development program and a user interface design program. And if you are interested in pursuing any of that, I will leave my number in the chat. You can reach out to me via text or email or phone call. But yeah, that is what these code talks are founded in, is vSchool. And Ben is actually a graduate of the program and now works full-time as a developer. So I'll turn the time over to Ben.
Thanks, Davey. Hey guys, so yeah, I remember, I think, some of you I've met before, I've seen here before, so welcome back. So today, I'm trying something a little different for today, as well as the next few ones. I decided to do a whole mini series on TypeScript. One reason being that it's too big of a topic to just kind of have an overview in 1 hour. And second of all, it gives me a chance to kind of do a bit more of a deep dive into one specific thing. So yeah, so I'm excited. I've actually been really excited about this one. This is going to be probably my most favorite one. So is anyone here who has not used TypeScript before?
I haven't used it, but heard about it. People always mention it.
Cool. Nice. And that's what this is for. This is for those of you who have maybe heard it on the grapevine, but haven't really used it. And even for those of you who have, gotten your hands wet with it, or feet wet with it, hands dirty, whatever. I screwed up that analogy. Anyways, it's for those people too. I've been developing professionally in TypeScript for the last couple of years, so I feel like I have a pretty good handle on it. But there's always new stuff that surprises me all the time. So the first thing is I am doing I decided to do TypeScript because I've found that it's just becoming the standard. I'm not going to say it's like going to replace JavaScript or anything, but like it's becoming the standard development tool because of how powerful it is. So one of the things that I love about TypeScript, let's back up. So TypeScript is just a programming language that's just based on JavaScript. It's commonly called a superset of JavaScript. And I'm going to pull up their document. I'm going to pull up their documentation right now. So on TypeScript lang.org, this is where you can find all the docs. So today what we're going to do is we're going to quickly just kind of get a project started. We're going to kind of talk about some broad strokes about what TypeScript is, what it does, why it's useful, as well as do a couple little examples. But next week is when we're going to really get into the actual syntax of it. But today I just want to make sure that everybody gets just like a good familiarization with what it is and why it exists and why people are using it. So, like I said, TypeScript is just a superset of JavaScript. What does that mean? That just means that it's a language that's based on JavaScript, And in fact, it's a transpiled language. What that means is that you type in a certain syntax, namely TypeScript, which of course you do in a TypeScript file. And you then run the TypeScript compiler, which then changes it from TypeScript syntax to plain good old fashioned JavaScript. So that's why it's called a transpiled language. It's making it's transitioning or transforming one syntax into another, basically. Does anybody have any questions about that? Cool.
Nope.
All right, so does anybody, oh, looks like you got a chat. So is it like Babel? So that's a good question. It's not Babel. Babel is just a generic program for transpiling generally, but Babel itself is not a language. It's kind of the mechanism for transpiling. Like there is a TypeScript compiler that you can use in Babel, but Babel itself is not a language. Babel is just a tool for transforming languages into other languages or past versions of languages like ES6 to ES5, for example. So TypeScript is a language. It's a language. What's unique about it is the fact that it is a TypeScript is it's a typed language. Does anyone here know what a typed language is? What a strongly typed language means?
Kind of where you would set all the types of your variables. So specify that in this example, first name is a string, last name is a string, etc.
Mm-hmm. Yeah, it's a way of defining what category a particular value falls into, what data type category. And as we know in JavaScript, sorry, I gotta wipe my screen off. As we know in JavaScript, there are, we got the basic types like numbers, strings, booleans. We got arrays, objects, we got functions. These are all, very basic types. And they make up the building blocks of the language. And so a typed language basically forces you to be very specific about what kind of type any given variable or any given value is. In JavaScript, normally we can write stuff like, let me show you an example. I'm going to be playing around in this a little bit today because this thing's pretty awesome. So on the documentation, feel free to play around in their playground. They just have this cool little feature where you can write TypeScript and it'll compile it into JavaScript in real time. It's pretty sweet. So normally in JavaScript we can do stuff like this. Let name. Actually, I'm going to do let age. Oh, welcome, Mia. We can do age equals 10. We can do age equals 10. We can do age equals. We can do stuff like this. Now, JavaScript is almost too lax. They're almost like an irresponsible uncle that just lets the kids do whatever the hell they want. And in the sense that you can define variables, they can be whatever type of value you want. And when you look at something, when you look at a value in JavaScript, it's not always clear what type it is. Whether it's maybe a function or whether it's an object or an array or something, it's not always always clear. You're kind of having to rely on either using the debugger to kind of step through each line of code. Other times you're kind of just basing it off of what the variable name is. You kind of hope that it's, you assume that it's what the variable says it is. Whereas in TypeScript, you have to enforce these types. And there's just a very specific syntax for how that works. So what I'm going to do is we'll start over here. Okay, so the most, let's see here. I'm trying to think if I want to start here. Yeah, okay, so I'm just going to do an example, and then we're going to kind of set up a project, and just so you guys can kind of see how this how you would apply this to a real project, because that's pretty important. But okay, so what I'm going to do is, now what's cool about TypeScript is, depending on how you configure it, there's this whole TypeScript config JSON file that you can use that basically tells the compiler how to go about its job. You can configure it to be as strict or as less strict as you want. And what's kind of cool is that normal JavaScript is perfectly valid syntax. So doing this is perfectly valid, depending on how strict you want your configuration to be. Okay, so however, one of the benefits of TypeScript is to write TypeScript, write using types. So there's a general syntax for TypeScript, and it goes and there's a lot of colons and there's a lot of angle brackets. So you're going to see a lot of colons like this, and you're going to see a lot of angle brackets. And that will become familiar to you as you play around. And what I'm going to do today is, at the end of this, I'm going to create a Git repository, send out a link, and let you guys kind of play around on your own, because that's how I've learned TypeScript. Is I basically got hired. I had never really done TypeScript other than what I learned in the interview, and basically I had learned by the seat of my pants. That's how I learned it. So the best way to learn it is to just play around with it. So okay, like we said, there's a few different data types. There's number, there's string, there's arrays, there's objects, there's booleans, etc. Now, if I'm defining a value, I want to tell it what type it is. So the most basic way to do that, let's say I'm writing a function. I'm running an add function. Okay, so my add function takes x and y and returns x plus y. Okay, cool. Now, notice how the compiler is yelling at me. What do you think that means?
You haven't specified a type.
Yeah, like if you define a variable, and that's essentially what these are, right? If you define a variable and your configuration is such as I've set it up here, this is just the default for the playground. It doesn't like having variables that are just kind of floating in the air like that. Like, we assume, as a human looking at this, we assume that those are numbers. But is there anything that prevents me from doing something like this in JavaScript?
Nope.
No. Those are perfectly valid values, and therefore they're perfectly valid arguments to a function. What TypeScript lets us do is enforce types. So I don't want this shouldn't be allowed, right? We want to enforce that those are numbers. Those can't be anything else other than numbers. So here's some syntax for you. Anytime there's a variable being declared, there's a good chance that you're going to be defining the value of it, or sorry, defining the type of it. And the syntax generally goes like this. It's the name of the variable followed by a colon followed by the type. Okay, so let's see what this is yelling at me for. What does that say?
It's not a number.
Yeah, I'm trying to put a string as an argument to a function that I've specifically said you take a number. So what's cool about this is that I catch this error before I even have to run this code. Okay, because normally what would happen if I were to run this, so let's console log, let's get the sum here, and let's console log the sum. Now in normal JavaScript, I'm gonna take this out for just a sec, just so we can see the answer. I'm hoping it will. Well, I can't get the logs to show up. I'd have to do it on my own. So normally what would happen though is I would get this, because those are strings. And when you add strings together, they just get concatenated, right? They just get put together. And that would be a problem. Although we wouldn't know that this was happening until we actually ran our program. TypeScript lets us kind of catch a lot of these things before that even happens. It won't even let us compile it, as you can see. Take this out. Right, because now we're going to see this. Oh, that's supposed to say number. Right, so now if I switch that to 2 and 4, let's see what I get. Oh, this doesn't. Oh, it doesn't actually run it. Oh, there we go. There we go. That's what I wanted. Okay, boom. There we go. 6. Whereas if those were strings, it would be 24. Right. See, that would be a problem. Cool. Okay, another thing that's kind of cool is with functions, you can, so let's look at this function. It has arguments, which are numbers. But another really helpful thing for functions is what type of value does it return? That's a really important piece of information to know. And this function, it's a sum function. So I would assume that it would output what type of value?
Number.
Yeah, it's a number. So again, here's that colon followed by a number. So it's a little strange looking, I know, but the idea is when you're defining a function, you define what types of arguments it have, and then you define what its output is. A lot of the time, sometimes you don't necessarily have to do this. It's kind of inferred. But I usually think it's a good idea to always define your output, unless it's really not necessary. What's awesome about this though is suppose I did something like this, where for whatever reason I accidentally put that in brackets. Well, let's see what it says. So type number in brackets, which is short for an array with numbers in it, is not assignable to type number. So again, this is an example where I've specifically determined what my output of my function is, and TypeScript is telling me, hey, no, that's not right. You said that it's a number. You're outputting an array. That doesn't work. That's not what you said. So again, this is very helpful. just from a development standpoint, to be able to catch these errors before you even run the code, it's pretty awesome. Does anybody have any questions so far?
I have a question.
Yeah, go ahead.
If we click on that.js, that is the version, the on top or in the second panel on top, there is that.js, like next to errors. No, next to DT. Yes, the first one. That.js, the first option. No,
You're talking
like
about?
no, the first option. That.js. Yeah, that one.
Oh, yeah.
So this is the real version that Java is the JavaScript, right? It's after it's transpiled. This is the real
Yep.
version that goes to the browser.
Exactly. So what I'm going to do right now is I'm going to actually start a TypeScript project so you guys can see how this, might occur in the real world. And this is actually, I'm glad you asked that question, because we're gonna kind of see where this comes from. Because right now playing in their playground is cool and it's fun and all, but like it's kind of like training wheels. It's kind of hard to see where it's very magical. So we're gonna actually do this in a real project.
Got it. But my question is that if it's that this is, I mean, I know this is the JavaScript because this is pure JavaScript and I know JavaScript. So all these numbers that are there, these type of notations, they're just removed. They're just for us, the developers, to help us. But then it doesn't go to the browser. It just, what it goes to the browser is just pure JavaScript, right? Back to JavaScript, if that makes sense.
If I'm understanding your question, yes. I mean, all TypeScript does is take a file, port it through some process, and produce a new file. And then that new file we can then use in the browser.
And that new file doesn't have no TypeScript, just JavaScript.
Right, because Node doesn't. If I try to make a TypeScript file and I try to say const hello, and I say, hey, you're a string, and I say, hey, string, cool, awesome, and I then try to run this in Node. Oops. Look at that. As far as it knows, like this is like, what are you doing? This is a syntax error, right? Like it's expecting an equal sign, but it doesn't know what that is. So yeah, we have to transpile it into something that either Node or the browser can understand. So that's what we're gonna do. Okay, so
Question on
go ahead.
setting those types. Would you ever do that like within what you're going to return? Obviously you put a number for the function, but would you do it within a sort of a return within your function? Or
like, what do you mean?
Like where you say return so you do it at the function level, not within kind of what it's going to return.
Right. Like if your function's returning something, you tell it what it is there. Now I could just as easily say, sum, which is a number, equals x plus y, and then I could return the sum. It's a little redundant because we already know those are numbers, and adding two numbers obviously is a number. But without defining the number type though, if I don't put that type guard there, then nothing really prevents me from doing like something like this. See how it's not yelling at me?
Yep.
It's only yelling at me if I define it here.
Got it.
Yep. And as you practice, you're going to kind of get used to these things. Okay, so let's go ahead. We're going to install TypeScript. We're also going to install ESLint because one of the best ways that I learned TypeScript was basically just to have my linter be like just nagging me constantly about what I'm doing wrong, because that's how you learn, by having someone over your shoulder yelling at you all day. I don't know about you guys, that's how I learn. Just kidding. All right, let's do this. Alrighty. Okay, sweet. All right.
What are you using TypeScript with? Is it React, Angular, or?
Okay, so TypeScript is just a node module. It's just a npm package.
You can use it with anything or all.
Literally
things.
anything. Yeah, it has nothing to do with any particular framework or anything, which
Nice.
allows you to use it in anything, which is pretty awesome. So just make this here. Alrighty. Okay, so I've got my lint installed and my TypeScript. Let me just initiate these. TSC is the command line for TypeScript. So let's just run the linter really quick. Just initiate a nice little project here. Syntax, okay. So my module, because this is gonna be TypeScript, I'm gonna be using JavaScript modules with import and export. Beautiful. Okay, I'm not gonna use it with React or anything. I'm just gonna do a plain vanilla node project. Does it use TypeScript? Yes, it does. In this case, we're gonna use it for the browser. So I'll do that, have it generated as a thing. There we go, install these guys. Okay, well that's going. I will make a folder. So it's just kind of convention to have a folder called source, which has your all of your TypeScript files, or we'll call them our source files, which then can be processed through TypeScript to output our output files, which is just going to be plain JavaScript. Okay, we got this nice ESLint here. Beautiful. Okay. Alrighty. Now what we're going to do is we're going to, the first thing you always want to do is, because we're using TypeScript, we have to define our compiler rules. That just means, that just gives TypeScript the instructions on how to take the TypeScript files and produce them into JavaScript. There's a bunch of different configurations and settings that allow us to be more or less strict, and we can change where they output to, how they output, all this crap. And we're just going to do some really, really basic stuff for today. So the way to do that is I'm going to run my tsc command. If you install it globally, you just can write tsc. I prefer not to install things globally as much as I can because of versioning. Okay, so we're going to do this, and then we're going to initiate my TypeScript project, which will, what did I do? What did I do wrong? That looks right. Just happen. What am I doing wrong? VM run TSC, that's what that is. Yeah, that looks good. Everything looks good. TypeScript's there. Okay.
Should there be 2 colons on line 9 in your package JSON? Because you have one after that. The
Oh my
initial.
gosh.
Well, I think wouldn't
Yes.
that one be all right?
And yeah, there we go. I don't know what.
There's still a typo in TSC.
Yeah. So
I I see what you're saying.
Yeah.
This is why you guys are here. I was like, what is going on? Okay, all right. I thought I was going crazy. Okay, beautiful. So as you can see, it created this configuration file. Beautiful. Okay, now don't be overwhelmed by this. It's a big file. But we're just going to focus on some very, very simple ones. Okay, the first thing we want to do, because this is a compiler or instructions for a compiler, what we want to do is we want to say, hey, take all of our code that we write in this folder, and I want you to output it to a different folder. So that setting is the outdir, this guy. And what we're going to do is we're going to call it dist. For whatever reason, it's become conventional to call it dist because that's what node modules use by default. Okay, source maps. So if you're debugging, these are really helpful. We're going to maybe play around with that. So I'm going to set that to true. This lib property, I will show you in a second. Right now, I'm going to leave that alone. And for now, is there anything else I want to point out? So this target property is saying, hey, what type of JavaScript, what version of JavaScript do you want to transpile to? Okay, this is the type of output. We're going to leave it ES5. Old school. It's old school, but not super old school. Okay, and this is saying what kind of module types they use. Well, CommonJS is the default, so we're going to stick with that. There's a bunch of different types, but we're going to stick with the defaults. Okay, and this is really all we need. Luckily, Typescript kind of comes packaged with all the defaults set to a pretty helpful spot. Cool. Now, if we look at our ESLint rules, notice that we're just kind of using we're using the defaults that were generated from our ESLint library with the TypeScript settings added. So we're just going to leave these as they are. As the linter pops up with stuff, I'll be pointing it out. Okie dokie. So first thing we're going to do is we're just going to do a very simple.
I'll ask you a quick question.
Go ahead.
The target, if we change the target to ES 2020, what is the difference between the target and module? I'm sorry, if we change module to ES 2020, that means I want to know the difference. That means that when we compile, the last version is in ES 2020 or is in ES5? What is the difference between target and module?
Okay, so target defines what version of JavaScript it's going to be compiled to. Module means what kind of module system is going to be used. So that means that, like, for example, if I'm in Node, I do stuff like this. Probably seen this before, right?
Yes.
Acquire. Okay, well, that is different than this. So depending on what you set your module as, it's going to do something like that. There's a lot more to it, but it just has to do with how you export and import stuff. It doesn't have anything to do with the actual content of the code. It just has to do with.
Gotcha. So in this case, because with in the ESLint, we did say that we're gonna use the browser. Should be ES something in the.
Yeah. So we said that we're gonna use in our what was it?
I believe in the ESLint we said that we're gonna use the browser.
Yes, browser. Yep.
So that means that we should use ES 2015 or something like that.
Yeah, so that means that for what we're doing, we're going to use just the normal import. So if I wanted path, I'd get path.
So should we change the module to ES something?
No, because this is the output. This is how we're writing. This is what our input is, whereas this is our output. This is what the generated files are going to look like. whereas our linter is looking at our code as we write it.
Got it. Thanks.
Okay, makes sense? Cool, that's a really good question. Okay, cool. So here's here's our source file. Now what I want to do is I want to show I need to compile this into code that my browser could use, right? Because we're gonna assume that we've got some HTML file that, and we want to interact with this thing. However, we can't do anything like this. Why not?
Because it needs to be transfiled into your dist folder.
Right. This is a TypeScript file. Browsers don't understand TypeScript. So this isn't going to work. So what we're going to do is we're going to assume that we're going to produce a file called dist.main.js. Notice this doesn't exist yet, but it will. And we'll let's do this. We'll give this guy a welcome message, and we'll leave this guy blank at first. Okay. So what we're going to do is grab our. Actually, you know what? Before I do that, let's just transpile this. So the way to do that, there's a couple of different ways. The easiest is we're just going to use that command, this guy right here. I'm just going to say npm run tsc. Okay, so by default, it's going to look at our tsconfig.json and compile it based on these rules. So hopefully, hey, look at that.
Nice.
And like that. So we got ourselves a nice little JavaScript file, as well as the source maps for if we wanted to use the debugger, which of course, maybe we will use if we have time, because it's cool. All right, so notice this really isn't that different from this, but it is. It's significantly different in some ways. It's using var, it's using ustrict, it's got some of this stuff here. So that's interesting. And you know what? I'm gonna just go to my linter and tell it to ignore anything that's in dist. Actually, I think that should just work. Yeah, it stopped listening. And I'm gonna add that to my git ignore. So because this is just compiled, we're not gonna actually play around in this. Okay, cool. So now if we go to my index.html, I've got that. So now we know that that exists. Okay, beautiful. So now if I were to run this, okay, here's my document. And if we look in the sources, check it out. There's my file right there. Sweet. Awesome. Okay, now the fun part is we actually want to, interact with this document. So the first thing we're going to do is we're just going to provide a message for that each one. Okay, so again, this is a little arbitrary, but it will show how cool this is. So the first thing I'm going to do is, so here's our message. I'm going to call it message. And what we're going to do is we're going to, just like in JavaScript, we're going to grab the document we're going to grab the element by the ID and insert the message in between the tags. So we'll just go ahead and grab our H1. Document.get element by ID. Notice my IDE is able to auto finish, auto complete, which makes me happy. Okay, called it what? Hello message, I think, or welcome message. Okay, cool. So there's my element. Here's my message, and what I'm going to do is I'm going to say h1.inner HTML, or now we'll say inner text is equal to our message. Okay, so here's our first compilation error. Now, does anyone know? Has anyone seen this syntax before?
That's new, right?
Yeah, it's
Chaining,
new.
optional
It's called
chaining.
optional chaining.
Yeah, it's called optional chaining. So which is cool. However, we have a little issue here. What do you think the problem is? Why would this be erroring out? That message is actually not very helpful. So can anyone kind of maybe think why this isn't working? Oh, I just gave it away.
Oh, because it could not exist.
Right, and why is that? Why does it think that this could potentially be null?
Because your H1 could return null.
Yeah, because just because I call this function with an ID, that doesn't necessarily mean that it exists, right? What if I had done a typo, or what if the page hadn't loaded yet and this thing didn't exist yet? It's very possible that this function does not guarantee you that you're going to get back an HTML element. So this is one of the benefits of TypeScript, because now you have to be very careful about what you think values are. So if we look at this function signature, notice how it says document.element by ID. It takes an ID, which is a string, but it returns either an HTML element or null. That's how we know that it's one of those things. Okay, so there's a cheater there. So in this case, we're smarter than TypeScript in the sense that for this particular case, we actually do know, we are very much aware that this will give us an element. But we have to tell TypeScript that. So what we're going to do is we're going to say, this thing is indeed an HTML element. Oops. This is I forget. Yeah, as HTML element. Notice by defining it as an HTML element, that error went away. And now it's able to compile.
But it could still return null.
It could. It very much could. But what we're doing is we're telling TypeScript that that's not the case. Because again, there's now an extra, there's kind of an extra, I guess, step here. There's the compile step and there's the run step. You've got runtime and compile time. We're doing everything we can so that this compiles in a way that we think is stable and reliable, so that when we run the code, we can be, much more sure that it's going to run correctly. This is just kind of an extra check. We could, of course, do something like this. If H1 is null, then, don't do anything. Otherwise, do this. So look at this. Look at how now I got rid of that as HTML element, and suddenly my compiler is actually it's smarter than we thought it was. If this isn't null, well, what's the only option? What's the only other option it is?
An HTML element.
It's an HTML element.
Can
Therefore, we
add
have
a
all the
question mark?
properties. We could, but it's redundant, and also it's going to yell at us because you can't actually use the assignment operator on an expression that has a question mark in it. We'd have to write that a little differently. But what this does is, now normally in JavaScript, we would probably forget to do something like this. It's very implicit that this could be null. What TypeScript is doing, forcing us to do, is to be explicit about the types that we're dealing with. Now, I know that seems like maybe it could add a little bit, it could be a little tedious. And I'll be honest with you, it kind of does sometimes. But the extra time and tedium that you invest in the beginning pays off in spades later on. I guarantee you. That's just been my experience. So a few extra lines of code here saves me hours of debugging and pulling my hair out later. So let's run this code. So if we look at our dist file, notice how this is still what it was before. So I'm going to have to run our compiler again. And check it out. There it is. And if we go to our, hey, look, there it is. Beautiful. There's my text.
So do you have to compile every time, or is there a watch?
Super glad you asked that question. Yes, there is a watch, and you can put it in the actual thing.
Oh,
So now what happens is if I run this, it's going to run it in watch mode. So now anytime I make a change, so let's say I put some exclamation points here and I save, hey, check it out. It detected a change in the file, compiles it. There it is. We see it live.
Nice.
Pretty rad. Okay, so there's a few things I want to point out here. Again, next week, we're going to talk a lot more about like syntax. Today, I wanted to focus on just that general process of taking code from one file type and converting it to another and using it. What I want to point out is the fact that it seems kind of magical that it knew that this was an HTML element to begin with. The fact that we're able to do this seems kind of magical. Like, how does it know that document exists, right? So if we go to our linter, let's see what happens if I take out my browser thing. I might have to actually reload the window for this to take effect. Should be yelling at me.
how do you reload?
Control Shift P, and then you just type in.
Reload. Okay.
It's usually the first one, yeah, or Control R. That should be yelling at me. Why is that yelling at me? Because I'm not using any lib. Oh, it must be cached. Anyways, it should be yelling at me. My linter shouldn't like that. Let me, if I take that out, maybe that will.
Maybe if you change in the ESLint to Node instead of browser, and you do it explicitly to Node.
I did. I took them out.
But by default, it has to be something. I believe browser is by default.
Oh, is it? Oh, maybe if I set it to false. I see what you're saying. Oh, that's bad syntax. Okay, well, it's not yelling at me. I want it to yell at me, but it's not. So not sure exactly offhand why that's still letting me get away with that. Anyways, it's not that important.
So it recognizes the document, the DOM,
Yeah,
basically.
yeah, and in fact, I think it might just do that by default. In fact, let me take, it might be this lib. Oh, yeah, okay, that's what it was. Oh, so Brian, to answer your question, right. Brian, to answer your question, every week, there is a, if you go to like vSchool has an Instagram, we put out our, there's a new meeting every week. And are you in Slack? Like Brian, are you a vSchool student? Or did you find
No,
this?
I'm a developer just interested in the TypeScript stuff. I'm on the JS Slack.
Oh, okay, cool. Yeah, if you go to the easiest place is probably the vSchool Instagram. If you have Instagram, we put out a thing every week because
Okay.
it's a new URL every time.
Okay. You guys looked at putting it on Meetup or something?
We're in this is a pretty new series, so we're still working on the best place to put everything out there. Well, we're supposed to have a website out. We were supposed to have it out last week. I need to talk to Matt and see if that's been uploaded yet, because that's ultimately we're gonna have like a specific website with all not only upcoming events but like all of the past events
Recordings and
too,
stuff.
recordings. Yeah.
Okay.
I believe it is in the Meetup app too. Like I got an email.
Oh, is it?
Yeah, from Mo in the Meetup app.
Oh, cool. Well,
Yeah.
that's awesome. I didn't know that.
Yeah, so the vSchool Meetup should be fine.
Sweet.
They also added in the LinkedIn.
Oh, yes, and it's on LinkedIn as well. Yes, thank you. Cool. And you can always I'm on LinkedIn as well. If you ever have any questions, just hit me up. Ben Turner is my name. Okay, so let's look at what we've got here. So my linter was actually not the problem. It was my config. I'm gonna put those back just so that they're back. Okay. Okay, so by default, it assumes that you're using the browser. Okay, but look what happens if, notice this lib property, it's empty. It doesn't have anything in it. So what this means is all the library files which are to be included. These mean all the like kind of pre-written types that you want to use for certain libraries. So the most obvious one would be the DOM, which is what I'm going to put here. So that gives you all of the DOM. And look, it came right back. Pretty awesome. I don't know why it's yelling at me suddenly for my global type array. What the hell does that mean? Anyways, not sure what that error is. Alrighty. So that is what that means. If I were using Node, then I could do like, I believe it comes with, there's like a whole bunch of different ones. So like ES6, if I were using, you know, ES6 is nice. So if I was using Node, then I'd want to be able to do stuff like, you know, process.environment, if you ever seen those guys. You know, those are some preloaded libraries that you can use.
So you could use anything and all things if you have like a server and a client.
Yep, yep, exactly. So for today, though, we're going to stick with just the DOM. I don't know what this is yelling at me for. It's really strange. I've never seen that before. Okay. Okay, so back to this guy. So as you can see, we are
I have a
being
quick
very,
question.
yeah, go ahead.
So based on, actually, I believe it was Dan's question. When we go to the code, like, yes. So in this case, this is everything here is JavaScript. Nothing is TypeScript right now. So if we declare in line number 1 as, I believe was, one second. That was as HTML element in line 1. Yes.
Like that?
Yeah. If we do that, then, and we didn't have h1 equal null, then still that doesn't fix the problem. So I guess what I'm trying to say, we have to be kind of like a smart how we use TypeScript, because it can give us false security that we're preventing something, but at the end of the day, this is converted to pure JavaScript, so it's not preventing anything.
Yeah, so in this case, so there's something to, so yeah, you're right. So this doesn't work. Because first of all, we're saying that this is an HTML element when really this type is a composite type. It's not just an HTML element. It's either an HTML element or null. So doing this is not actually correct. We're assigning a value. See how it says type HTML element or null is not assignable to type HTML element. This is a really common error that you're going to see all the time as you explore your TypeScript skills. This is bad. We're saying we're trying to say, hey, you're H1, you're an HTML element, when really we're trying to assign this type to whatever the return type of this is, and it clashes. So I could do this, which would then fix it, but this could be seen as a little redundant, only because we already know that this function returns that type. So removing that kind of just takes away the redundancy, in my opinion.
I believe in the beginning you put it at the end, right? You put it after.
I did this as HTML element, which allows us to do this without having to do that type check.
But that's
So again,
that's exactly my question. If we do that, this as HTML element, is this TypeScript or JavaScript? I've never done that before.
This is TypeScript.
Okay, if we
this would not work in JavaScript.
Okay, if we do this TypeScript, this is giving us a sense of security, but at the end of the day, when this is converted to pure JavaScript, it's not securing that this is not going to be equal to null. It still can be equal to null, right?
Correct. Yes, this is not something that you want to do unless you know exactly why you're doing it. This is in this particular case, this seems like a much better way of handling it.
Okay.
And we're not really defining any types here because everything's kind of already been determined ahead of time. We already know that that's either an element or null. So then we're just simply applying logic. One thing to notice, again, this, I could do this, but it's yelling at me because it's saying type string is trivially inferred from a string literal. Okay, so this is redundant. It's obvious that that's a string. This is a constant variable, so this can't ever be reassigned. There's no reason to define that as a string. It is a string. We're literally defining as a string, so it can't be anything else. This, however, would be a problem because let, again, can be redefined. There's nothing stopping me from doing this, and then we have a problem. we have to be very careful about how we define things. And again, next week, we're going to talk a lot more about these specific kinds of things. This is meant to be just kind of a bird's eye view. So again, this is
So it really makes you like a better programmer.
100%. Yeah, I'm a way better programmer because of this, because it basically kind of puts you through the ringer, and it takes away, it forces you to like look at the assumptions you're making in your code. It forces you to be very, very aware of what your types are. So for example, to kind of get this point across is, let's say I have some object. Let's do something. Okay, so let's say I have a person. Okay, and let's say I want to do something with this person, such as I want to reduce. I want to create an HTML element that represents this. So this is common in something like React, where you take some data, some object data, and you convert it into a React element, which just means you convert it into a form that your browser can understand, right? If I were to try to render this on the browser, it wouldn't really work, and it would either look weird or it would just straight up break. You know, I can't just say h1.innerText equals this. I'm not going to get anything useful. So I need to convert it. So let's say convert to HTML. Okay, and again, this is a bird's eye view. I'm not going to explain every little thing I'm doing. This is just to give you an idea of the kinds of things you can do with TypeScript. It's really cool. So the idea here is to take a person object and render an HTML element containing person data. Okay, that's the idea. Okay, so we're going to assume that this is a person. Okay, first thing to notice, I've got my linter is already freaking out at me. It's saying it's assigned a value but never used. Here's a function that's assigned a value, it's never used. Here's the key right here. Person is declared but its value is never read, but look at this. Person implicitly has an any type. Well, okay, that's interesting. How do I does anyone happen to know offhand how you define, how would I define the type of this? Seems like there's lots of types. I've got a string, I've got a number, I've got an array of strings. How might I represent that? Yeah, it's an object. In TypeScript, they're called interfaces. This is really cool. We can define the shapes of things. And again, we're going to talk about this next week, but we're going to define person as an interface. Okay, it has a name, which is a string, it has an age, which is a number, and it has hobbies, which is an array of strings. This is how you denote that. Okay, sweet. Now here, and I'm gonna, instead of calling this person, I'm gonna call this me. And me, I am a person. Pretty cool. So just so you can kind of see, if I tried to add a property here, check it out. It's saying that invalid does not exist on type person. So I can't just add properties willy-nilly anymore. I have to be very careful about what I add. Pretty cool. All right, so now my function here, its job, of course, is to return a HTML element from a person. And what I love about the linter is that it's going to be yelling at me throughout this until it compiles, which is saying, okay, right now it's telling me a function whose declared type is neither void or any must return a value. Okay, well, right now this function's not returning an HTML element. So it's telling me, it's like, hey, bro, what are you doing? So we've got to, write our function. So that's what I'm going to do. So the first thing to do is, well, why don't we create an element? So we'll create our header, which is going to be document.create element. And this one will be like an H3 tag. What the hell? And then it'll have our, that'll be my name, I suppose. So header.inner text is equal to person dot. What's cool is that because I've defined this interface and because I have a linter and TypeScript and VS Code, check it out. It actually knows it has a name. That's pretty awesome. I love that. And we'll do this. And there's my header, and then we'll do our subheader, which will just be my name. This will just be a H5, I guess. Doesn't really matter what this is. And again, we'll just say subheader dot inner text. And again, it's really awesome because TypeScript knows what types these all return. It's able to auto complete all these things, which is just fantastic. Okay, age, person age. Okay. And then hobbies. I'm just gonna get really lazy with this. Let's call this our list, which is just a span, I guess. I don't know. What are we doing?
P tag.
I'm going to use a list just for that. I'm going to use like an actual UL. And then for each header, for each hobby, wait, why is it saying that that's a, wait, what? Why is it saying that's an object? That doesn't make any sense. It's a string. It's an array of strings. What the hell? Okay, so we'll just say our list dot, or wait, we gotta create line. I hope you guys appreciate React now.
You're making it look easy.
So again, we'll just do our inner text equals hobby, which of course is a string. Okay, I'm actually kind of baffled right now. Why is it saying that that's a, why is it saying that's an object? That's really, okay, I'm kind of confused. What the hell? That doesn't make any sense.
Because your config file isn't.
This is really weird. Dude, I'm just gonna reload this window. My VS Code's being weird. I don't know what the hell's going on. I've done TypeScript long enough that I know exactly what that means. Dude, did I spell it wrong? No. No. What if I change it? I wonder if person's already, that wouldn't make any sense that it's already built in. What is going on? This is so strange.
Isn't dumb with lowercase? I don't know if that will make a difference.
It reads it as either one. Something is very weird. Like this error is very strange to me. Really, I'm genuinely baffled, to be honest with you, about what is going on here. I'm going to see what happens if I take that out.
Maybe we can console log.
Yeah, I'm gonna have to look up
Hobbies.
that error after. I'm not sure what's going on with that because now it's working. So yeah, there's something wrong with the way that it was parsing this JSON file. I don't know what's causing it. I'll look at that later because now this is working fine. Like this is how you define a string or an array of strings, I promise. Okay, there we go. So now it knows that that exists. Beautiful. Okay, so back to what we're doing. Okay, here's this. We're going to create our list element. We're then going to append our list, or append our list to that thing. Okay, beautiful. Okay, and then finally at the end of this, we'll go to our HTML. Here's our div. We'll call it our person div. This is all very arbitrary. Then what we'll do is, okay, that's all that, beautiful, beautiful. We'll then go ahead and get our person. I'll just call it a div. And then we know that this is, so if there's no div, we're going to do something else. Otherwise, we're going to div.append child, the result of our convert to HTML with our, or this is me. Okay, notice it's yelling at me still because I still haven't returned anything. I've created all these elements, but of course we need to create our wrapper, which I'll just make that as a div. Sorry, this is so tedious, almost there. Okay, so we will append our, we've got our header, we've got our subheader, and then we have our list. So for each of these, we will simply append our thing. So wrapper.append child element. Okay, beautiful. Return the wrapper. Okay, notice this should now compile. Yep, no errors. We are now sure that this guy takes a person, it outputs an HTML element, everything's fine. Beautiful. All right, let's see if it worked. Oh, I stopped my. I'm gonna run my command. Okay. Oh, and I'm not running my, because I restarted my VS Code. Check it out.
Nice.
Okay, so this is a somewhat trivial example. But what I love about this is the fact that, what I love about TypeScript is the fact that it does force you to think about exactly what you're doing. And it also gives you a lot more familiarity with just like things that you use every day. Like it's kind of cool, at least it is for me, to like, if I'm curious about what other properties does this thing have, like you can easily just kind of go through them all. It's kind of nice. So you don't have to remember like, ah, what was that method called? Stuff like that. It's all just kind of there because TypeScript provides it for you.
Is that if statement kind of a standard pattern for, you know, an HTML element? Like when you're, yeah, using something that could return null?
Yeah. And in fact, there's an even better way to write this. I would probably just do this. Yeah, because like it's very, especially when you're dealing with like a really complex web application, when you know different things are loading at different times, you don't want to try to perform an action on an element until you know that it actually exists.
The hobbies. If they don't have any hobby, can we go to the interface? And now we can use the question mark. I was thinking first to do hobbies, string, or undefined, but I guess I'm not talking about undefined. I'm talking about not defined. So how would
Are you
handle
saying,
if
you
they don't
mean
have,
like, you're saying like, what if I didn't provide this?
like if they don't have any hobbies, like hobbies is gonna be empty.
Okay, so if it's empty, then we don't have a problem because it simply will loop through an empty array, and we have no problems. But suppose I do like where you're going with this. There are lots of options, such as, let's say that just to give you an idea of some powerful things that you can do with TypeScript. And again, we're gonna start with like the real basic syntax stuff next week, but just so you can kind of see some cool stuff you can do with this. Let's say that I have some special kind of person, like, I don't know, a superhero. Okay, a superhero extends a person, so it's gonna have all the properties that a person has.
Wow. OP.
But we're gonna have our superpower, which of course my superpower, well, okay, superpowers are just gonna be a string. Okay, so suppose, let's see here. So we'll call this, let's do, do you mind if I use you? This will just be fun.
That's fine.
So what's your, so obviously it's Giovanni. I don't know how old you are. I'm gonna guess 25.
Okay.
Hobbies, what are your hobbies?
Coding, not just, I don't know, coding, play video games.
Cool. Anything else you want to add?
Soccer, tennis.
I'll just do soccer. All right. Okay. Now, because you're a superhero, notice it's yelling at me because I'm missing a property. I need to have superpower. What's your superpower? Can you like see around corners? Are you invisible?
Can fly.
All right. Fly. That's pretty awesome. Okay. So notice in this case, person doesn't have a superpower, or a normal person doesn't have a superpower. So my person, in this case, it assumes that it's got a superpower. But okay, we could also assume that this is a superhero, but then we have a problem. Now it's yelling at me because, hey, convert to HTML, you only take superheroes. Well, we don't want that. We want to be diverse, right? We want to have the superhero people and just the normal people, right? Like this, you know, we don't discriminate. We still want to show your information. So we can do stuff like this. Now we can say, okay, if you're a person, so if person dot superpower. So we can say, let me think the best way to write this. Because what we want to be able to do is we want to ask the question like, hey, are you a normal person or are you a superhero? All of our code here basically assumes that you're just a normal person, right? But we also want to make room for, okay, well, if you're a superhero, then we want to handle stuff here. So now I could do something like this potentially. Let's see if it lets us do this. So if person has a superpower, doesn't exist. That's interesting, right? Saying that.
That's right, because we're sending in lines 54.
Yeah, so we're saying that, you know, you're either a person or a superhero, but okay, this isn't quite, so that's not working.
It's not working because in line 54 we're sending in line 52 you're sending me, which doesn't have superpower.
Right, but the thing is that we want to be able to do something like this.
Oh.
Right? Our function, we should be able to handle both of these cases.
Oh, I see.
Right?
I guess
We don't care whether or not you're a superhero or a person. We want to be able to handle it. So it looks like this isn't going to work. So what we can do is we can do something like this, where this will look a little weird, but we can do something like this: person as superhero dot superpower. So if you have a superpower, then we'll render it. So that's one way to check that you're a superpower. We could also, let's see here. This is like kind of the common way. This is the common way to do it. Because the thing is that there's not like some universal way to tell that one thing is an interface or there's not really a way to differentiate between instances of an interface. If we were using classes, then we could do that, but I didn't want to get into classes today. So this allows us to handle this case where, okay, well, what if you're a superhero, right?
I believe if we do JavaScript, we can say like if the person has own property and then we put superpower.
Sure, and that could work too. The problem is well, first of all, it's just not a very TypeScript way to do it, and in fact, TypeScript doesn't even really like this. TypeScript sees this as a problem. It's not really TypeScript, it's just our linter rules. Just because this is kind of a flaky method, it's not always very reliable.
I see.
So it's much better to access the actual property. So let's see here. Yeah, so this is a pretty reliable way of saying, hey, you're a superhero. And then we could, of course, render your superpower. Oh, just to save time, I'm not gonna do that here. But there is a lot more you can read about it in the TypeScript documentation where it talks about conditional types. Here. Forget what section it's in.
It seems like a very nice documentation.
Say what?
It seems like a very nice documentation.
Yeah, it is very good for sure. So, oh, I forgot about the in keyword. You can also do this. You can say if superpower in person. That also works. See, now it actually sees it. So that one's kind of nice as well. Bye, Emily. You're welcome.
Bye, bye, bye. Bye.
Bye.
Yeah, so there's a few ways to do it. This one's actually kind of clean. I just forgot about that way because I never do it that way. If we were using classes, we could do something like this. We can say like if person is an instance of something. I don't think it works with interfaces though. I've never actually tried, but like, yeah, like it's not a class. So if it were a class, then I'd be able to do this. And this would probably be a pretty effective way of doing what I'm wanting to do in this situation. Yeah, so that's just like a couple of things you can do with TypeScript. Now, the hardest part for me in TypeScript were kind of figuring out these interfaces and figuring out kind of the either or kind of thing. There's also the opposite of or, which is of course and, which is kind of a combination type. We've barely scratched the surface though. There's so many things in TypeScript. That's why I'm splitting this up into 6 different episodes because there's just so much. But I don't know. I feel like this is a good quick little overview of just to get a taste of what you're doing.
Is interface still the right way to do it if you have functions within your objects? Does that kind of cover all objects?
Oh, yes, that's a good question. So yes, for sure. You can definitely use methods on your interfaces. If you are finding yourself using methods in your classes though, you do have to ask yourself the question. So for example, here's the function that returns a string. Oh wait, oops, what am I doing? So like, for example, let's say a person had a speak function. Okay, this is how you define a method on an interface. So this is perfectly acceptable. It's perfectly fine. However, you do kind of want to ask yourself at times whether or not you would be better served by using a class instead of an interface. And that's a much bigger question that I don't want to get into right now. But yes, the short answer is yes, you can totally do that. But it does bring up kind of a Pandora's box of, whether to use a class as opposed to an interface. It also depends on whether you're using more class-based inheritance in your code or if you're using more functional programming. So for example, in fact, I've got a great example of this in a project that I've been working on. Open recent. Okay, yeah, it was this one, I think. Okay, so here's a project I've been working on recently. I wanted to set up just like a basic boilerplate TypeScript project with testing already like set up and bootstrapped. And here is an example of a case where having methods on your interface was kind of helpful. Oh, it was in test. I made some test utilities. Okay, for example. So check it out. Here's an interface that's just nothing but functions. I did that on purpose because I'm not really, so a class is good for when you need to maintain some internal state and your methods are ways in which you interact with that internal state. Whereas this is just a bunch of methods. It's just a library of methods that I wanted. So they're just static objects with methods. And basically I just have functions that output objects that have methods, and that's it. There's no fancy state or anything. They're all just methods. That's it.
Is that
Good old functional programming.
Is that testing or that's something just checking?
Yeah, this is for running tests. These are all my methods this is all the methods that are on a test bed. It's a thing that lets you, all I was doing was writing methods that you could use in your tests. So like if you're testing something, like here's my example of testing
your testing also needs to be called TS, the extension.
Say that again?
Well, makes sense. The testing files also needs to be extension TS because you're testing TS files.
Right, yeah. All my tests are written in TypeScript as well. So yeah, all I did was write this test bed library. So you pass in your database connection and then you just have access to these methods. So it's just easy for when you want to like seed your database and stuff. But anyway, so like this is an example of a TypeScript project or something that you could do in TypeScript. So this is a node, just a very basic playground in Express, but like you can see that it's TypeScript. You've got these imports here, you've got everything's a TypeScript file. So here's an example of I'm defining types here. Here's a promise. In this case, you get an array of promises, or sorry, a promise with an array of things. These brackets we'll become more familiar with as we start using what are called generic types. That's, I think, later though, because that's a pretty advanced type that is pretty abstract, kind of hard to get your head around at first. But as you can see, there's just like examples. Hey, look at this. This is where I'm assuming it's a string. Here's the case where I have some interface that I've defined over here. What's cool about TypeScript is that you can export interfaces the way that just like you can export anything else. It's pretty awesome. Here's probably, I'm actually pretty proud of this function right here. You're welcome, Austin. See ya. So I'm actually pretty proud of this function because this is really exploits TypeScript in a lot of really cool ways. I'm using generic types to produce this object here. So it's using all sorts of patterns. It's mostly functional programming patterns and generic types. You're exploiting them to its fullest capacity, which is pretty awesome. That's what all these weird things are. This probably looks totally crazy, which you'll just get familiar with.
I was about to say, like, if this is open source, then, and you use TypeScript, you limit yourself for contributors, right? Because then you need to understand this, which is, even I know JavaScript, I don't understand this because I need to learn TypeScript to understand this. Yeah, I guess my question is like, I guess that's one disadvantage, right? That not everybody will understand your code.
Yeah, like TypeScript is just becoming more and more standard. Like so many libraries are just built with TypeScript. And it's going to just become more and more ubiquitous in everything. Like React has TypeScript now. I mean, it's had TypeScript support for a while. Angular, I don't even know if Angular's, what is it? They're on like 10 now. I don't even know if you can do it without TypeScript. In fact, I think you're forced to use TypeScript in Angular nowadays.
I heard this library from the same creator of Node that is called Dino.
Yeah, Dino's written in TypeScript. Yep.
You don't need to transpile to JavaScript because
right. It's all built in. Yeah, I haven't had a chance to actually look at Dino, but I've read about it and it actually seems really cool. I just haven't had a chance to play around with it yet. But yeah, it's really cool because then you don't really need to worry about doing any of this fancy stuff. Like I've got all these like different configurations and crap, but with Dino, it seems like a lot of that's kind of done for you, which is cool.
I have a basic question.
Yeah.
Can we go back to the file that we were doing two numbers in the browser?
Sure.
Because now I know how to articulate my question.
Yep. Yeah, I'll go back to that file.
No, it's in the browser. It's the one that we were doing in the playground in the browser. Can you go back? I guess if you go back.
Yeah, I'm not sure it saved it, but we can do whatever.
Is that one exactly?
Okay,
that
it saved it. Sweet.
Yep. Well, it was return x plus y instead of brackets. Yep. So in this exercise, I guess I'm trying to understand the philosophy of TypeScript. I understand that we do numbers, and I just want to choose this one because this one is very simple. And then we are safe because we're declaring numbers and we only take numbers. But if this is a form, the user can enter anything, can enter a string, can enter whatever they want. How TypeScript help us in that way?
So you really just have to think about it in terms of what are the only types that are available so if you're in a form, then the only data you can really deal with are strings. So however, your database, assuming you're building some web application with a server and a database, well, your database doesn't just contain strings. It could very well contain numbers and Booleans and dates and arrays and things, right? Much more complicated things than just strings. So because of that, you need to be aware of how you take your form data, which of course they're just raw strings. But at some point, let's say you're doing a post request. Let's say you're doing a post request with an object that looks kind of like, you're doing a post request that looks like this. Okay, so in your form, those are both strings, but in your in the body of your post request, those are both, one of them's a number, one of them's a string, because it's a JSON file, right? So your code is going to have to, make those transformations. And having those type guards with TypeScript can be very useful, and then can prevent you from accidentally sending that as a string, because you don't want to know that that was a string until, or you don't want to find out that that was a string after it's already been added to the database, right?
I understand now. Because in the post request thing, age is gonna have a string, and I'm saying number, it's gonna give me an error, even though I don't see anything there.
Right, because so for example, let's say I have a, this has a, this uses the DOM, I think it uses the DOM. Yeah, okay, so suppose I have some input. We're just gonna have to pretend that there's an input, because there isn't actually an input, but, oh, oops. Okay, okay, so let's pretend. We're gonna assume that I have some input. Right, and so on my input, I can very much, so on my change, right, I have my event. Now, I know that if I get my raw value dot value, so telling at me because the target, it doesn't really know what that is. So if there's no target, we'll just okay, well, we already know that this is a HTML input. So notice that's a string, right? We therefore know that that's a string.
Yeah.
Well, if I'm gonna send this to my database, send to database. Obviously, this is not real code, but it's fine. Then I'm gonna want to put my, let's say it's age, raw value. Well, if that's a string and my function, let's call this const send to database, is a function that takes age as a number, does stuff, whatever it may be. So here we have a beautiful example of where TypeScript catches our problem. Oh, sorry, that should say raw value. Okay. So that is a beautiful example of how TypeScript can help us in this situation.
I really like how you were able to pseudocode this. So cool, super cool.
Yeah,
Makes sense.
so I have to be able to, or I can use TypeScript to then be like, oh yeah, that's right, this is a string. I know this is a string because this is coming from an HTML element. If I need to put this in my database, then I better change that to a number. And hey, look at that, now it works. Obviously, this isn't doing anything, but hopefully that gets the point across.
Yeah.
Cool. Oh, I don't know why. Why is that red? There we go. So yeah, there's kind of a trivial example.
It's cool. Super cool.
Yeah. Yeah, is it anybody else have any questions? We've got like five minutes left or so of the code talk.
I was curious on that source map, the debugging part, but I'm guessing that's
yeah.
a bit of a bigger question.
No, I'm glad you asked that. Yeah, we got time. This is awesome. Do you have a specific question about it, or did you just want to kind of see it in action?
Yeah, just see it in action.
All right, let me go back to my code. Actually, you know what? I'll just spin this guy up because this is where you can see. No, I don't want to. I want you guys to see how it's getting put together. Go back to my TS intro.
And then basically to kind of summarize getting started, it's like npm install ESLint and TypeScript, init your linter with that sort of answer those questions based on what you're doing, and then just run your TypeScript command.
Yeah.
Cool.
Yep. Yeah, and just remember to install it. I'll have this. I'm going to create a repository for this, so you can use this as a template if you'd like.
Sweet. Thank you, Giovanni.
I took some notes if you.
Okay, awesome.
If that
Yeah,
helps.
he just sent some stuff in the chat, which is helpful. Yeah. So yeah, it's just the just remember to install it as a dev dependency. I mean, it's not gonna not work. It's just that this isn't really a dependency that your code uses to rely on. It's just it's what you use as a developer. So just remember to do the save dev flag.
You can use also -D, capital D.
Right.
And that's what I use. I don't know if it's the same thing. I believe it's exactly the same thing.
Yeah, that's what it is. Cool. All right. So what I'm gonna do is we're gonna run this guy as we're gonna use the debugger here, which is super fun. Okay. So just debugging 101. Our TS config, we're saying to render source maps, not render, just build source maps. All those it's just a way to tell the debugger as it's going through our compiled code, which as you look at this is, normal JavaScript. And as you can see, this is not the same as this. In fact, this code has far fewer lines than this code. So with that being the case, that means that, if I put a line break here, how is it supposed to know to stop? Like, where's it going to know to stop, right?
Right.
So that's what the source map is doing. Basically, the debugger is looking at this code, looking at, oh, there's a source map here. It looks at this file, and then this has all the instructions to convert where the breakpoints belong. That's the short of it. I honestly don't know how it works, to be honest with you. So, yeah, comment that out. Okay, so let's say we put our breakpoint here, and I'm using VS Code, but you could use whatever program you want. But VS Code gives us some pretty awesome ways to do this. So what I'm going to do is we're going to do inspect, and I'm going to run my main.js file. Not defined. What is she talking about?
Superhero.
Oh, duh. I'm an idiot. This is Node. I can't run this this is a browser project. So I'm just going to use the Chrome browser. One sec. do this. Let's There we go. Okay. This is, I believe, 5,500. Okay. Okay. Oh, here we go. Okay. There we go. So as you can see, my function just got called, my convert to HTML function. So we're breaking inside of there. And there we go. There's person. We got the hobbies. They're all there. And notice that it's stopping in our TypeScript file, which is what we want. You never want the breakpoints to happen in your compiled files because that's hard to read and it doesn't really help you that much, especially if it was minified. That would be just awful. So here you go. So here's your wrapper. Here's your, of course, is a div, as you can see there. It's got all this cool stuff. There's a lot happening. And then if we want to put a breakpoint in there, we can then see each hobby. We're at music. The next step, we got coding. Next step, we've got skateboarding. We go down, there's our list item, which again is just a big giant HTML element. Beautiful. Then at the end, let's put a breakpoint right at the return statement there, or right there. And that's the, no, not the end of the program. That. And that's the end of the run.
Cool.
So yeah, I mean, there's 1,000 different ways to configure this stuff.
So the source map allows you to run the debugger basically.
Right. Yeah. Because if I ran this, like if I turned the source map off,
and when you inspect in like Chrome DevTools, you would be looking at the compiled code, basically.
Sorry, say that again.
If you were inspecting within Chrome's DevTools, you'd be inspecting the compiled JavaScript.
Yes. Yes. Although Chrome does actually have the ability to follow your source map. So for example,
oh, cool.
Let's if I were to run this guy. Okay, cool. Okay, we've got our this sweet. Okay, so yes, if we go to our sources, obviously this is dist, and while this isn't too bad, you can imagine this would be pretty terrible. But you could, there are ways in Chrome. You go to your file system and you can like add stuff to you could like add your source code to there, and then you could put your breakpoints in your source code there.
Oh, cool.
Yeah. So
sweet.
Pretty cool.
Okay. All right. Looks like we're out of time. Thanks for another great session.
Yeah, I hope that was helpful. Not too much info.
Oh, it's been like, floating around all the TypeScript stuff. It's like, well, where do you start? It doesn't, like on the surface, seem that much different, but I'm sure as you get into it, there's a bit more nuance, but obviously really helps.
Cool.
Thanks, Ben. See you next week.
Yep.
Yeah, thanks, Ben.